Welcome back again. Here we go. Now we want to continue our lecture on physical quantities. We said to measure length, straight lines, we can use a rule like this rule. We start from 0 and we measure 22.5 centimeters. Now, if we count the space here between 22 and 23, we have 10 little markings here. So each of them is called a tenth. So we can say 22 and 5/10. But if we split using this one, we see that we split into two equal parts. So that's 22.5. Then here on the inches rule, if we measure the same distance, let's see. Measure the same distance, what do we get? We get 8 full inches. And then with these small markings, we see that we split the 1 unit between 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8. So here is at the 7th mark. So this is 7/8. So here is 8 and 7/8 of an inch. So you write it as 8. Ooh, let me get it a little bigger. So we'll write it as 8 and 8 full and then 7/8 of an inch. An inch is IN, like that. But in this other case, we'll say 22 and that will be 5/10 or just half. So it will be 22 and we have 10 markings in between and we are at the 5th. So 22 and 5/10, and that will be in centimeters. All right, now let's push it forward. Let's move forward. So here we have an inch rule. We can take the inch rule there and we measure. Here we have 2 and what's the spaces here? We have 1, 2, 3, 4. So that will be 1/4, 2/4, 3/4, or 1/4, 2/4, 3/4. So 2 whole unit and 3/4. So we'll write that as 2 and then you give space 3 on 4, 3/4 inches long, right? And what about the arrow? Be careful, take your 0 here at the edge. And then at the tail end there, we have 8 and 1/4 because we have 4 space between each space is 1/4. So we have 8 and 1/4 like this, inches long. All right, we won't go further. Can you do that? So try that. Let's go to the next. Now we're using the centimeter rule. Now, centimeter, from here to the end, we have 17 centimeters. So the screwdriver is 17 centimeters long. What about the fork? The fork, remember your 0 at one tail here. At this one end 0, and then at the other end, we take the reading 15 centimeters long. So do you know how to use your centimeter rule? If yes, we are done. Oh, is this a slug? All right, so let's measure the slug, the eyes here, because the eyes are farther to the left. And then now we can see the tail at the 11 mark. So don't come and measure the slug like this. Be very careful. Go to the farthest end. And we get 11. Okay, so we'll end here. You can do the rest, or you can join us at our online classes so that you can have this tool to continue learning with us. Now, the next thing to measure is called area. So we started with length. Now let's look at area. So length is just how long or how far things are. So that's length. We're done with length. Number 2, area. So what is area? Area now is the space. So if you have a distance like this, we'll have a boundary. So this is an enclosed distance, an enclosed space rather. Is an enclosed space. And now we want to see what physical measure will measure how much space. So that's the question we're asking. How much space is inside this enclosed space? So you should have an enclosed space before we can now start talking about this. So for a line, if we have two lines, we just have to measure the length either in inches or centimeters. We have other measurements like meters, kilometers, miles, feet, yards. All right. So here I can take my ruler and measure, and then I will get the exact measurement, and I can know by how much one is longer than the other, or by how much one is shorter than the other. Now, what if I have two different spaces? What if I have two different spaces? I have this space, I have this space. So how can I compare them? Like this. How can I compare them? That is what we are focusing on right now. Now, to do that is very, very easy. Now we have to find a new way to measure. Like the length here, we can measure in inches and centimeters. So what is that measurement we get for space? So how do we measure space? Ladies and gentlemen, my students, friends, parents, we measure space using squares. You see, for length, we can just count the length using a specific length called centimeter. So we can say this is 1 centimeter, and then we add another one, 2 centimeters, 3 centimeters. So centimeter is a particular small length. So we stack the length up, 4 centimeters. We keep stacking, 5 centimeters, 6 centimeters, 7 centimeters, and a little bit. And this little bit, if we break a centimeter into tenths, maybe this will be like 3/10. So 7 centimeters and 3/10. So that is how we make up the length. Now, what about the space? How do we fill up this space? To fill up the space, we have to make square. What is a square? And exactly what is a centimeter square? When you see the right centimeter square, what does this mean? Now we know a square is a shape like this with equal parts, right? So if we make something like this, this is a full square. So we will fill this space of a full square. This is what we call now a full square with a space that is filled. So if you fill this space, this is what we call a centimeter square. A centimeter square. So this is the centimeter square, and exactly here is just 1. So that is 1 centimeter square. And we're going to use this centimeter square to fill up the space. To fill up the space. We're going to use that to fill up the space. And to do that, we will do it as such. They're asking us shade in the rectangle with an area. Shade in the rectangle with an area of 18 square units. So if I just pick here, I shade 18 square units. Okay. So you see, this is a square, 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 like that. If we count them, we have 18 squares. So that is how we measure area, by using squares. And then your square will determine what type of square, and what you will say after this 18 is, I made squares of centimeter, just like how we make a square, 1 centimeter by 1 centimeter. So, and then you fill that space in that square, and then we'll use this space now to fill each of this square. And then this shaded area has a space of 18 centimeter square. All right. So it says excellent. Now here we need 42. 42. Okay, is that 42? Yeah, that is 42. Ooh, that's not 42. We need one more. Okay, correct. And you asked me, teacher, how are you getting it so fast? Okay, here we need 28. That is it. Yeah, great job. All right, now they need 48. Now you can also count one by one, but it's a rectangle. So 1, 2, 3, 4, 5, 6. Oh, that's 6 now, and then you count down 1, 1, 2, 3, 4, 5, 6, 7, 8. So if I take 8 and I take another 8, I'll make 2 8s, 2 8s, and then 3 8s, and then 4 8s, 5 8s, 6 8s is 48. So that's how I'm doing it. So if I take 8 units here and 6 units there, I'm going to make 48 squares in the middle. So you see why we say the area of a rectangle is the length times the width, or the width times the length. In this case, we have the width and the height. Okay? So if you multiply it, so if you have 8 is the unit here, if this is 8, the length, okay, again, we're talking about the length here, right? If you measure here is 8 units, then if you measure here it's 6 units, and you see that this is 1 unit, 2 units, 3 units, 4 units, and each of these units is just a side of the square. So a square will actually hang here, right? So, and we'll have 6 units here, and that will be 6 centimeters long. And then here we'll have 8 units, that will be 8 centimeters long. Then you want to ask yourself, this is a rectangle because you have 2 parallel lines this way and 2 parallel lines. So what is the space inside this? It's just the number of units here, and the number of units here will be exactly, you count it, 6 times 8 will be 48, will be exactly the number of squares that we have enclosed inside. All right, so area has meanings. So areas just mean squares. So if you're having these squares, it means a square like this, and 48 of them will fill this space. So once you get your square, you have to note what kind of square do you have. We can have a square of a decimeter square, where it will be 1 decimeter by 1 decimeter. It will be like this. And this square, we can fill areas faster. And sometimes if we fill this area with this decimeter, we'll still have some space that we can use full decimeter to fill. That is why we'll choose a smaller one. And then sometimes they can give you a space. Sometimes you can have a space like this. Sorry there. We can have a much smaller space. We can have a much smaller space, maybe like this. And they ask us to fill it. And to fill it, we might choose different squares, a much smaller square like this, and we can call this a millimeter square. We can use a much smaller square, and we go and fill the space with a much smaller square. 1, 2, 3, and we count how many of these smaller squares we use to fill it, and then that will be the answer of the area, or the space inside this shape. So area means the space inside, and we have to use specific squares, millimeter squares, centimeter squares, decimeter squares to measure these areas. All right. So again, area is something we should understand. Now here we can count. We see that these are just 4, but if we need, say, shade a shape, so we can add this one. It makes 5 squares, 6 squares, 7 squares, 8 squares, 9 squares, 10 squares, 11 squares, 12 squares. So this is still an area of 12 square units. They're asking us to shade 9. Well, I can shade 9 as 3 by 3. That would be okay. But I can also as well shade 6 here, and I shade the 3 extra ones here. This space still has the same area as just doing your 9 like this. Yeah. So these two, they have the same area, is the same amount of space we feel in this shape and also in this shape like this, the same amount of space. So again, space can be crooked, can be regular shapes. These shapes are regular, or can be irregular shapes like this. Can be irregular shapes like this. And how do we find the space or the area inside here? We can use bigger squares like this and even smaller squares. For example, I can say maybe this will contain maybe 13 centimeter squares, since the centimeter squares are bigger. And then for the smaller edges like this, I use millimeters, and then 16 millimeter squares. All right. So you can write your total area like this. Or we can find how to translate millimeter squares to centimeter squares. All right, we can find that knowledge. And then let's see if we can do it here. All right. So let's see. Let's see if we can do it here, my friends. You see how this is interesting. Okay, let's talk this. Okay, so if this length is a centimeter, so bear with me, decimeter, let's use decimeter. So this is a decimeter square. So this is 1 decimeter, and this distance here is also 1 decimeter, okay? Also 1 decimeter wide, and that 1 decimeter high. Okay, but we know that 1 decimeter is made up of 10 centimeter. So if I say this is 1 decimeter by 1 decimeter, 1 times 1 is 1. So this square is 1 decimeter square. 1 decimeter square. Okay, and we know 1 decimeter has how many centimeter? 1 decimeter equals 10 centimeters. 1 decimeter equals 10 centimeters. So you see that if we break this distance into 10 equal parts, we'll make each of those parts will be called each of those parts will be called a centimeter. So here, from here, this side, right up to here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of them is a centimeter. So if this is 0, this will be 1 centimeter. This will be 2 centimeter, 3, 4, 5, 6, 7, 8, 9, 10. We get here will be 10 centimeters. So each of this is 10 centimeters. Therefore, this square is a centimeter square, 1 centimeter by 1 centimeter. This another centimeter square, another centimeter square, another centimeter square. Now, how many centimeters square do we fill this entire space? 100 of them. 10 times 10, 100 of them. So you see 1 decimeter square is not 10 centimeters square like here. 1 decimeter square is actually 100 centimeter square. So again, to change units from one to the other, so if I have a very large space, maybe the space goes like this, covers like this. Okay, I see that the space has 1 centimeter, 1 decimeter square is already in this space. How to fill these others, the smaller spaces? I can now use you see centimeter squares like this to go and be filling all these other spaces. Yeah, all these other spaces, fill them with centimeter square. Fill until I can fill all the spaces, and I count all the, even here I fill and I count all the centimeter squares, including this 100. Instead of me saying it's gonna, if I count all these small centimeter squares that I fill up, and maybe I have like 40 extra, oh, it will not be up to 40, all this extra white space around this. maybe let's say 19. So if I have extra 19 centimeters square, in fact, that square is just called centimeter square like this. So this is the meaning. If you just write centimeter square, that's the meaning. It's this square. This is a centimeter square, okay? Centimeter square. Each of this space here is a centimeter square. This space in here is a centimeter square. All right. So instead of me saying that this area is 1 decimeter square and 19 centimeters square, I just change everything to centimeter square. So that is 100 centimeters square and 19 centimeters square. I have 119 centimeters square. So that I would know that that is how many such squares can fill up this area, 119 of them. So that's how we express area. All right, I hope this one has been helpful to us. All right, and we have more questions in our online school where they can ask you which two shapes have the same area. So this is 8 centimeters squares or 8 square units. And here, if we count here, we have 6 plus these two 8. So these two shapes have the same area, okay? And let's see. Whoa, this is 4, this is 5, this is also 5. So the 5 and the 5, different shapes, but the same area. This is 6, this is 4, this is 6. So this and this, the same area. So again, area is squares to fill the space. We use squares. And squares of different sizes. Millimeter square, centimeter square, decimeter square, meter square, kilometer square, mile square, yard square, feet square, inches square, all right? Depending on where you are. If you are in America, you use the customary system where we measure in inches, feet, yards, miles. If you're in Europe, China, or Asia, Africa, or the rest of the world, you use the metric system where we measure in meters square, kilometers squares. All right, see you. Bye. Bye. So again, if we have 3 units, that's the length here, and we have 5 units, you can just use 3 times 5 to know that we'll have 15 squares inside. So that is why we say the area of a rectangle is the length times the width, because these are perfect shapes where we can fit perfect squares inside, and it will align with that. So welcome to that, and we have 15 square units. If your unit is centimeter, it will be 15 square centimeters. If your unit is decimeter, it will be 15 squares, decimeter squares of decimeter is called square decimeter or decimeter squares. All right. I hope this class has been helpful to you to understand the meaning behind area or space in a bounded or enclosed shape. All right. And this shape is a 2D shape, not a ball. It's like a circle. We can have like shapes like circles, like this, shapes like this. And we want to feel like how much space is inside these types of shapes, or even crooked shapes, or maybe a triangle like this. We find how much space is inside. Or sometimes we can have the crooked shapes and we ask how much space is inside this, how much space is inside, like this white part. That is area. Then if you draw a box and you ask how much space is inside the box, that is another kind of space. For example, if I have a box like this, well, you know how to draw your box? Yeah, so if I draw a box and you're asking me how much space is inside the box, that will be called volume or capacity. So that is, we'll be using small box of size centimeters and we'll make cubes. So we'll be using how many cubes are we filling the space inside. So it will be like this. You'll see that you can fill it with, yeah, maybe 3 cubes. And if we have like that, here, we can count the number of cubes we feed here and then there, going down there. Here, going down, if we draw going down there, we'll see that here we have 1, 2, 3, 4. At each level, you have 1, 2, 3, 4, 5, 6 cubes. Since we have 2 levels, we have 6 cubes, and the other 6 cubes on this second level. Altogether, we'll have 12 cubes. So the volume, and this time not area, the volume will be 12. If the cubes are of sizes centimeters, it will be 12 centimeter cubes. So you see, when you say centimeter cube, it's actually a real meaning. This thing has a physical meaning, centimeter cube. It's a cube of size centimeter. So you make a cube of size centimeter here, 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 centimeter here. So a cube of size centimeter to fill the 3D space inside. So here is a space like the space in your room. So again, if you get big boxes, huge boxes, how many of those boxes can fill your room? That will be the volume. You can just say 20 boxes, and that will be the volume of your room. Then if you know that the boxes are boxes of meter square, they will be like the boxes of sides, all the different sides are 1 meter, then it will be those numbers of meter cube. So that cube will be called a meter cube. But if it's the size of centimeter, that cube is called a centimeter cube. So here we have a space of, an inside space of 12 centimeter cubes. So for spaces that are flat spaces, we can fill flat spaces with squares, centimeter squares. If we put the 2 up there, it means squares. Or we can fill them with cubes, centimeter cubes. You put this 3 here, it means cube. You see where we're putting the 3 as a superscript up, centimeter square. If it's just a length, we just measure how long or how far. We measure it just centimeter. So from centimeter, it's just one side, centimeter, just length, then square, 2 sides, cubes, 3 sides. The length, the width, and the height. All right, I hope this class has been helpful, even though it's extended. All right, see you in the next one.